this is Junichiro Horikawa, and this is the third episode of VEX for Algorithmic Design. And the topic today is about parameters. So what are the parameters? Parameters is input values for each individual node, like geometry network node, which you can find on a parameter window right here. And you can use those input values to control some specific functions over each node has. For example, if you change the translate input values for geometry node, you can change the position of this geometry node. You can also change the rotation, scales, and so on. So there are many parameters which is used for different purposes. In this video tutorial, I'm going to show you some different types of parameters, then how you can create them, and then relate with a VEX code so that you can use those parameters as a user interface to control a VEX code. And in addition, I'm going to show you some basics of parameter expressions as well. Okay, first of all, let's look at the different types of parameters. So create a geometry network like this by right-clicking on a object network and search for the geometry and place it, and then double-click on the geometry node that you have created. And inside this geometry network, let's try to create some simple geometry like sphere first. Now if you click this sphere, and on the right top panel right here, you should be able to see a parameter window right here. If you don't see the parameter window, then go to this plus button, then look for the parameters. Then you'll be able to create a parameter window. And if you look at the parameter window, you see some bunch of different parameter types, such as a pull-down menu like these. In order to change the types of geometry, you see a value parameter, which you can change those numerical values yourself. There are also a slider parameters that you can use to control them. Now, first of all, let's try to create those kind of different parameters by yourself. Now, in order to create a parameter, you can actually create your own parameters on any kind of node, including this sphere node. But to make it simple, that you will be able to notice that the parameters are created by yourself, I'm going to create a parameters on a null node, since the null node itself doesn't have any initial parameters. So let's search for a null node, then place it on a canvas, and let's name this params types. Now if you have created a null node, currently there are no parameters inside this parameter window, so let's try to create some different kind of parameters. And in order to create parameters for each node, how you can do that, you can go to a gear icon on a parameter window like here, and there is a menu called Edit Parameter Interface. So click that, and you'll be able to open a Edit Parameter Interface, a parameter editor window. And you can add your own parameters using this parameter editor window. So let's try to do that. If you open up the parameter editor window, what you see on the left side is the list of parameters you can use to show up in a parameter window. And right now, and the actual parameters that you have in each node is listed on the middle window right here. And currently you don't really see any parameters listed, just this loot, which is invisible at this moment. So currently there are no input. So in order to add the input parameters for this node, for this null node, what you need to do is to drag and drop the parameters type that you want to use from left to the middle, then promote it to this parameter window. So let's try to do that by drag and drop this float parameters first, like this. drag and drop this float from the left to middle, and then click apply button. Then if you check the parameter window for this new node, you see that the new parameter has been created with the slider, and by changing the slider, the values in this channel box is changing like this. Now when you click the parameter you have just created, you see some different kinds of options that you can change for this parameter, this specific parameters, such as name, label, type, unit, size, and so on. Now the label is just a text shown inside the parameter window right here. So if you change this name, then the label string right here on the parameter window will also change. But this is not an actual ID, so you can have a similar name. You can have the same name even if you have multiple parameters. So let's try to change this to float value to see if this changes. So I have just changed the name to float value, and then if I click apply, you see that the value has been changed based on this value. Now if you try to change this name as well to a float value, you see that the additional underscore has been created if I pressed space. That is because since this is a ID value, you cannot have any space characters, so all the space will be converted into underscore to make it as one letter. So if I click apply, nothing will change, just the ID has been changed, and this is really important value in order to access it later on from VEX code or channel expressions. Now if you're using a float parameters right now, you see that when I have created the values, the range of the sliders is from 0 to 10, and that is the default range for the float value. You can actually change this range. Sometimes you want to have a range between 0 to 360, or maybe 0 to 1, or so on. So in order to change the minimum and maximum range of this float slider value, you go back to the parameter interface and then click the value that you want to control the range, and then inside the right hand side pane you see an option called range right here. So currently the default value is between 0 to 10, but when you click this toggle on the left side of this range, then you'll be able to actually change the minimum and maximum of this slider value. So if I set it to -1 to +1, then apply, then the slider range will become from -1 to 1. So this is pretty important to know, that you can also control the range of the sliders for your custom UIs. Now let's try out other types of parameters, essential parameters that I often use for myself. One is integer parameters, one is a string parameters, and one is a float vector 3 parameters, and one is a color parameters. One could be a file parameters, and then this car ramp float and ramp color. Maybe as an addition, let's try to bring up the toggle, then and order the menu. Now click apply and see that a bunch of different kinds of parameters has been generated like this. So if you go from top, so the first one was the float value that we have created initially. The second value is integer parameters, which you can change the sliders to define the integer value stepping by 1 like this. And you can also change the range for this integer value as well. Okay, so the third one is a string parameter. And for the string parameters, you can type a text value like this, ABC text, something like this. So this is not a numerical number, but this is a text channel that you can use to type in strings. Okay, the fourth parameters are the vector parameter. It says as float vector 3. So you have 3 different parameters on one row like this, and you can use them to have something like a directional vector value to change both 3 values. Could be used for positions, could be used for directions, and so on. Now next parameter is color parameter, and for the color parameter it is actually similar parameter equal to a vector parameter because it has 1, 2, 3 different values that you can change. And for the vector value it was x, y, and z value, but for the color value it's going to be R, G, and B. But actually both are pretty much the same data type, which is a 3 vector value, vector 3 value. And what's special about color parameters is that you have additional color editor interface right here, and if you click this button you can actually change the color values right here by using this special color interface. And if you have set the color, you see that this RGB value being updated automatically based on this color that you have selected. And the output value is actually a vector value, just that the interface looking is a bit different compared to a normal float vector. The next parameter that I'm going to show you is a file parameter right here. Type is file. And for the file parameters, what you can define here is a actual file path, like a external geometry file or like external HIP file. And what's special about this file path parameter is that you have this icon on the right hand side right here. If you click this, you can actually choose the file which you want to refer to. Like for example, if you want to refer to this 01 attribute.hip, you can specify a file path to the file that you have defined inside this user interface. And if you look at carefully, this is actually equivalent to this string parameter. You can type in a string like this. So instead of using this file icon, you can also type your own string. Just writing this same text will give you exactly the same output. So instead of using the file path, you can also just copy and paste it on the string as well in order to use it as a file path. So it doesn't really matter. It's pretty much the equivalent. It's both of those 2 parameters are a string parameters, just that this file parameter has an additional interface right here in order to let you choose the file using this special file dialog. That's what's special about it. Next 2 parameters called ramp parameters are a bit special one, which is those 2 graphical parameters right here. These are a bit different compared to other parameters because this itself doesn't really give you any values by itself, but it is used with another value in order to remap the input value to create another output value. I'm going to explain about this later on, how you can use those ramp values, but just to make it understandable, to make the introduction to these ramp parameters, try open up this float ramp parameter type by clicking this button. Then you see this curve right here, linear curve like here, and currently you see that there is an axis for x-axis and y-axis, and each axis have its value from 0 to 1 for x and 0 to 1 for the y, as you can see right here. And this line right here is used to remap the x value to y value. So if you input a value like 0.7 for x, then the actual output value that you get out of this float ramp parameter is a y value, which is equivalent to this x equal to 0.7. So if you look at the y value on the x equal 0.7, then it is actually equal to y equal 0.7 as well. But this is because the line is linear, like a straight line from 0 to 1. But if you change the curve like this, you can click inside this curve editor to add control points like this. So in this case, if the x value, if input x value is 0.7, then if you go look up, then the actual y value for this 0.7 position is equal to 0.2. So this float ramp parameter can be used to remap the input value to custom custom values dependent on this curve shape. And this is really used for a lot of cases, and using with VEX is really a good idea, so I'm going to explain how you can do that later on. And that's the same for a color ramp parameter as well. So I'm going to explain this well later on. Now, as an additional parameters, there is something like toggle parameter. Like here you see on the parameter window, you can use this parameter to actually have an interactive toggle button like this to make it on and off. And the result of this value is actually 0 or 1. So it is a integer output value. If the toggle is off, then the output value of this parameter is equal to 0. If toggle button is on, the output parameter value is equal to 1. So it's pretty simple parameter interface, but it is useful when you have on and off situations in order to control a geometry condition and so on. So sometimes if you just want to change the types 0 or 1, then this toggle is a good way to use that. If you have several options, then sometimes just using integer parameter is a good idea. Like if you have 3 types to change with, then it might be a good idea to use the sliders, integer sliders. But if you only have 2 types conditions to change, then the toggle might work for you. Now, last parameter type I want to show you is called order menu. And if you look at the parameter window, you see something like this. So this is a pull-down menu that you can create by yourself, similar to this options created within a color ramp parameters. So you can create your own ordered menu as well. And to create a menu list, go to a parameter editor window, then click the ordered menu. Then if you go to the menu options, menu tab on the right hand corner, you see some lists here on the menu items tab. And this is where you can add your own menu items. The token is a string based ID of your items, and the right hand side is the label is the actual name that is shown inside right here as a name. So let's try to create a single item by saying the token is equal to A, and the label say blossom. Okay, so if you have created the item like this and type enter, then one item has been created. And if you click apply on the editor window, you see that the one item has been added named as blossom, and it is equivalent to this label value right here. In order to add multiple items for ordered menu, click on the empty menu right here underneath the blossom token, and then typing another token value together with the label. Let's say this is the rose, and the third one, let's say the token is equal to C, and the value, the label is equal to, say, sunflower. Okay, and click apply, and then the additional item has been added to this ordered menu right here. So, and this menu items is useful when you want to access to specific types of strings. You can access to the token value ABC, or you can also access to the ordered index number. The first one is equal to 0, the second one is equal to 1, and third one is equal to 2. So you can either access to the token value or the ordered index value using this label, using this ordered menu. So whenever you want to change like the types of geometry or something like that, this ordered menu is pretty useful. And I'm going to show you how you can access all those parameters in several ways. Okay, but before doing that, let's rename all those parameters so that you can know which parameter is which. So go back to the integer parameter, and for this one I'm going to name this int value. For the string, I'm gonna name this string value. For the vector value. For the color value, the file value. For the ramp, float ramp value for the first one, and for the second one is a color ramp value. And then for the toggle, I'm gonna say toggle value. The last one, menu value. Okay, click apply, and all those labels and names has been updated like this. So after you have created those parameters, currently no parameter is related to anything. So what you want to do is to relate those parameters in order to use them for some controllable input value, such as that the float value could be used for scale for the geometry and so on. So let's close the parameter editor window first. Then try to bring up a geometry like sphere, and let's use this sphere in order to use those parameters to change some of the controlling parameters like scales, radius, translation, so on. Right, so go back to a float value, go back to the null node, and you see the bunch of parameters that you've created. Now let's try to bring this float value, link this float value to a uniform scale of this sphere so that you can control this sphere radius by using this value. So what you want to do is by changing this value, you want to control the radius of this uniform scale value. The currently two different slider is being separated, but there is a way to link those two parameters, this parameter and this uniform scale parameters. To do that, the simplest way to do that is first go to a parameter that you want to use as a controller, which in this case this float value. Then right click on a parameter label or inside a channel box. Then click copy parameter. Now the parameter information has been copied to your clipboard. Then go to a sphere and go to where you want to paste the parameter information to. So in this case, this uniform scale. So go to the uniform scale and right click on a label. Then the next thing you want to do is to say click paste relative references. This will give you a channel expressions using ch function in order to link with a specific parameters that you have copied from. So in this case, this is a float value parameter inside a params types, and if you look at the expression here, you see that the parameters type. This is the name of this new node, and this is, and you have slash, and this is the name of your actual parameter name. And this is different from this label here. You see that you have an underscore right here. So this is, if you go back to the edit parameter interface, what you are using is this name value instead of this one. This label is just the one that is shown inside this parameter window, but actually in order to create a reference, in order to create a link between two parameters, what you often use is this name value, which is the equivalent to a ID of the parameter. So whenever you have changed your name to like float value 1, apply. Then if you go back to the sphere and check the uniform scale, then the name value has been changed likewise. Okay, now let's go back again and change it back to a float value. All right. So this is the simplest way to link two parameters like this. So it's the same for all the other parameters except for the ramp values. So let's try to use the integer value by copying the parameter and then paste it like to the center x, which will change the x coordinate of this sphere like this. So if you change this integer value, the x coordinate will be changed. If you copy this vector value right here, let's copy this parameter and maybe paste it on a radius right here. Then both all x, y, and z value is being copied from these x, y, and z. Now currently all those values are 0, so the sphere radius is equivalent to 0 right now, but let's change this to some random value. This, as you can see, well, every x, y, and z value is equivalent to the radius of its x and y and z value for the sphere. Now go down to a toggle value. As I told you, the toggle value gives you either 0 or 1. So if you right click to the toggle value, you can also copy this parameter. Then let's paste that to a center y value right here. In order to paste the single parameter, you just click on the channel box and then right click and say paste relative reference. Now currently the value is equal to 0 right now because the toggle value is off, but if you click it, the geometry has been raised up for 1 to y direction, and if you check the sphere, then the value became 1. And that indicates that the toggle value is either 0 or 1, like this. Now the string value can also be copied, like these one, string value or file value, or this menu value right here. So to use that, let's try with the other geometry like font. Show this up, and as you can see here, if you type a text inside this text box, you can create a geometry which is written as a character right here. Let me set the background color to dark so that I can see it a little bit better, like this. Now, in order to use the value written here as a word that's going to be written as a geometry right here, what you want to do is to copy this parameter again by right-clicking the label for the string value, like this. Then go back to the font, and what you can do is to right-click and then say paste relative reference. And now the text you have written here has been transferred to the font text like this. And anything you write here will be updated and used as a text. Now there is a bit of difference between the channel you have copied from a float value like these to this one. You see this back quote character enclosing this channel expressions right here. This back quote is used whenever you want to use a channel inside a text box like these ones. Without those back quote, what you get is just typing the exact channel string that you have written here. But in order to use this as an actual function inside a text box, then you need to type in this back quote. You need to enclose the function with this back quote like this. And when you just copy the parameter and paste it, the back quote will be produced automatically, so you don't really need to worry about that. Now let's also try to bring up this menu value right here. So copy this menu value, copy parameter, then go to a font, maybe have a return key new line, and then paste it by using paste relative reference right here. Okay, I guess the initial value has been removed and the new value has been created, but that's fine. Now currently the type value 8 has been drawn, and that is equivalent to a token value of this blossom label right here. So if you change this to rose, it becomes B. If you want to show up the sunflower, if you choose the sunflower, the token value it's going to be drawn, and then it's equal to C. If you check the edit parameter interface again for the menu values, go to the menu, you see that these are the value that you are displaying right now. So if you change this to AA or BB or CC, then the update token will be used. There is another value that you can retrieve from this ordered menu, which is a ordered index value. So the first one will become 0, the second one will be 1, and the third one is equal to 2. To get that, I'm going to explain about it later on together with the VEX. Now we have some ideas about the basics of parameters, how you can link the parameter from one to another. Let's try to access those parameter value from a VEX code. So first, let me show you the essential way to access to the parameter values using a VEX. So first, I'm going to create a simple geometry like sphere, and let's change this to polygon for now. Right. Then bring up a wrangle node called point wrangle. And let's name this wrangle like types of referencing params values. So I'm going to show you the essential way to refer to a parameter values from VEX code like point wrangle. So let's think about how you can refer to one of the parameters inside this params types. New node, then in this case maybe I can access to this float value right here and use this float value and use this inside a VEX code, a node wrangle, to control some of the property of this sphere. So how do you do that? Let's say you want to change the height of this whole geometry, maybe upward in a y direction, using this float value. So go back to the information about changing the attribute. What you want to do in order to control the point position is first accessing to a point position attribute, which is called at capital P. In this case, if you just want to choose move on the y direction, then you can access it by typing .y. So, and each point has a different y value. The point that is on the xz plane should have a y value equal to 0. For example, these point value might have a y value equal to 1. This one might have a value equal to -1. So each point has a different value, so in order to move them, all those points up and down with a constant value, what you can do is to say plus equal, like this. Plus equal means that keep the y value as it is and then add additional value to this whole y value, whole point y value. So if you say 1, like this, then the whole geometry will raise up to y direction by 1. If you say -1, then it will go down right here. So what you want to do is to change this value to a channel value, the parameter value that is defined here. So let's try to do that. The first thing you might think of is to just copy the parameter from here, like we did right here by using a paste relative reference. So let's try to do that first. So copy this float value by right-clicking the float value, and then choose copy parameter. Then go to a Rango node and remove those float value. Then within this line, right-click and say paste relative reference, and this will give you something similar expressions that you saw inside this font right here. And by using this, by just saying paste relative reference, you can actually copy and paste the link directly like this. And as you can see, the position of the circle has been updated based on this parameter that you have just referred to. So if you change the sliders, you see that the sphere position, the y value is changing depending on this float value, like this. So that looks good. Now, there is other ways you can access to this channel, to this parameter box, parameter values, instead of using just copy and paste. But just typing, if you look carefully at this value right here, this indicates the actual path for that attribute or for that parameter value that you want to use. So using those information, you can use another method in order to access to the parameter value. So for now, let's comment this out like this and try to use another method. Now, I haven't really talked about the VEX functions, but the VEX language has its own special functions you can use to do some special operations, and within that there is a function in order to retrieve the parameter value, which is called channel reference. And there are a bunch of channel reference related functions inside of VEX, like ch, ch2, chf, and so on. And I'm just going to show you some basic essential functions that you can use in daily basis for algorithmic designs. Now, the most essential functions you can use is called ch, which is used to retrieve the channel value, and ch function can be used for a lot of types of values, including float, integer, string, vector, and so on. So let's try to use this. In order to use this, let's type in @p.y plus equal and use the ch. And this inside the ch, what you need to type is the path to a parameter value that you want to use, and that is equal to the value right here, which you have been copied from the parameter directly. So let's just copy this value string and then paste it inside ch parenthesis. Now, as a result, what you get is the same result. By changing the float value, you can change the y value like this. So in this case, you didn't need this backquote together with this expression called chs. Now, CH and CHS seems pretty close in terms of the name, but the difference is that CHS function inside of VEX gives you a result in a string data type. And if you go to the VEX functions reference page and search for CHS, which is this one, and click on it, the description says evaluate the channel and return its value, and the return value is actually a string, so it's a text file. But as you can see, this at p.y is a numerical value, so you cannot directly use this string value like this. So the back quote exists in order to change this string value and forcing it to be a numerical value. So by using the quote value, you can kind of cast this string value into a float value inside of Xcode. So that's what's it doing when you copy the parameter and use paste parameter references. And that is equivalent to this one as well. This will just give you a direct numerical value by just using a ch function. Now, using ch is really useful because it can convert to any kind of data types. If you're trying to look for the float values, then this will just give you the converted float value. This will convert the value into float. If you look into a string value, then this will also convert the value to string as well. But there are cases that you might need to specify what kind of data types you're referring to instead of letting this function, ch function, estimate what the data type is. So in that case, there is a specific functions, channel functions for each data types, like for float, for integers, for string, and so on. And you already have tried special ch functions for the string, which is this one, chs. So S stands for the string. So together with the channel ch with the s characters, it indicates that this chs function is checking the parameter value of a string. So there, same for integers, float, and vectors, and so on. There are similar special channel functions for all those different data types. So for the integers, that will be chi, like this. So output will always be integers. If you're looking for the float value, then that is chf. If you're looking for the vectors, that will be chv, and so on. So if you want to retrieve the exact data types, if you know the exact data types that you want to retrieve, then go to the VEX functions reference page for the Houdini and check what kind of channel vector function that you can use to retrieve that. So in this case, we want to retrieve the float value. So what we can use is chf and use the same path to the parameter value, and you can actually get the exact same value like this. So let's try to retrieve other kind of data types using the similar method like here. So I'm gonna create another point wrangle here and connect it with this sphere. I'm gonna name this different data types. Okay, so first parameters that we want to try out is the integer value right here. And let's say we want to use this integer value to move the sphere to, maybe this time, to x direction. So what we can use, first of all, we can access to a x coordinate by typing at p.x. Then similar to the y direction, I'm going to type plus equal to add a value to the current x coordinate. And then what we want to retrieve is the integer value. So in this case, we're going to use the special function called chi. and inside this parameter parenthesis, we want to type the actual path to the parameter for this integer value. So this time let's try to type it from scratch. So first of all, type // This means that we're searching for this current network inside this current network. Then type the name of the node that you're looking at. So it should be this name. So copy this, params type, then type / and by typing / you're looking into inside this param null node. Oops. And what we want to retrieve is integer value. And in order to retrieve this value, you need to know the actual name of this parameter instead of this label name. So in order to get the actual name of this parameter, you can always go back to the edit parameter interface and check the integer value right here. Go to the parameter tab, and this is the actual name that you want to use in order to access to this parameter. Not this label, but this name value right here. So let's copy this, and then go back to the wrangle and type int value right here. Now the integer value has been imported. I think if I change the integer value right here, integer sliders right here, you see that the geometry is moving to x direction by 1, like this. So that looks good. Now what if we want to retrieve the string value, like this one, using a special function like chi? So in this case, we want to use a chs function, that is a channel function, in order to retrieve the string value. So the sphere itself doesn't really have a string related function right here, or parameters right here. So I could just create a string attribute like a text, then say accessing to the parameter values // params types, and this time the name of the value was string value. Let's say, now in order to check this value, go to a geometry spreadsheet by going to a new pane tab, inspectors, and geometry spreadsheet, select geometry spreadsheet, this. And right now I'm using a point wrangle, so go to the point tab, and there you see a new attribute called text, and inside the text the parameter value has been transferred like this. So that's also success. Now let's also try to bring up like a vector value right here. So for this one, maybe I can use this to again use that to scale the x and y and z value. So using it as a radius multiplier. To do that, what you just need to do is to multiply this at p by the value that you're going to import from the parameters. And in order to retrieve the vector parameter value, what you use is chv. And inside this parameter parenthesis, you type a similar channel value like this. So I'm just going to copy it until this. Then after the slash, the name of the vector value was vector underscore value. Okay, spell mistake, vector. Right, so I think the geometry has been scaled based on the x, y, and z value inside this vector, inside this param tab's vector value right here. So if I change this x, y, and z, the scale of the sphere changes corresponds to these vector value right here. Now the color value is similar to a vector value because it is still a x, y, and z value. But the interface is a bit different, so let's try to use this color value to directly change the color of the sphere. So to do that, if you remember from the last attribute basics video, in order to change the color of each point is to access this at CD. And this time I'm just going to override the at CD attribute using a same CHV function because we're going to retrieve the vector value x, y, and z, but the name of the parameter was a color value. So change this vector to color. Oops. I need a semicolon to close the line. Right. Now it is currently the color is white, but let's try to change this color value by using this color interface. As you can see, the value, the color itself changes corresponds to this color editor. And actually the value that being transferred is these x, y, and z value. And right now x value is 1 and y equals 0.737 and z equals 0.56. And if you go back to the Rango node, go to the geometry spreadsheet to the point, you see that the CD attribute has exactly the same value right here, and that indicates the actual color, L, G, and B. Right, so that's for the vectors. So these are the essential channel functions that we use in daily basis when it gets to a procedural modeling, including a CHF for the float value. So by remembering those 4 different kind of channel functions, I think in most cases that will be fine. Using this works quite well, but there is one problem using this method, is that you see that I have typed the parameter name hard-coded way, like typing inside the VEX coding editor like this. But the problem with this is that whenever you change the name of the parameter, like string value or int value, then you also need to change the value, the name of the parameters inside the VEX code as well. So let's try that out. Going back to the parameter types, no node, go to the edit parameter interface. Then if I change the name of the int value to say int value 2 and apply. Now currently the int value is let's say current int value is equal to 3, but actually by changing the int value, you see that there's no change occurred with this geometry anymore, which means that the link has been broken between the parameters, between the null parameters to this VEX code. That is because the name is different right here. So in order to use the same parameter like we did last time, then we have to rename this parameter name after we have named right here. So now it works like this. So that's a bit of problematic if you want to refactor the HIP file after you have created a bunch of parameters with temporary names, but in the last case you might want to rename those to more prettier names. Then in that way, all those links has been broken if you have typed it hard-coded way. So you have to rename this again in order to use it. So in order to avoid the broken links, broken reference between the parameter values, there is a bit better way for VEX code in order to link the reference. Okay, so to do that, I'm going to create another point wrangle, and I'm gonna name this promote parameter like this, and connect with the sphere like this. Then what I'm gonna do is to create another channel within this Rango node right here underneath this VEX expression text box. And And after you have created the additional parameter value within the Rango node, what you want to do is to link the parameter that you want to actually use from a params types null node, for example this float value, by copying this value, then paste it as a reference to a newly created parameter channel underneath this VEX expression code editor. And then the link is going to be more solid. The value has been transferred from here to the new parameter channel of this Rango node. Then this parameter value will then be transferred to within the VEX and can be used. And in this way, even if you have changed the name of the parameters like the float value to float value 2, it automatically changes, it automatically updates the channel names if you use the paste relative reference within the channel. So as a result, you don't really need to change the name for the attribute within the VEX code. So the refactoring should be more easy. So let's try to create a channel within this Rango node. What you can do is either go to a edit parameter interface for the Rango node and do the same thing as we did for the null node, like drag and drop this float value like here, and say fval, apply, accept, and you have a additional float parameters right here. Now, the next thing we want to do is to copy the parameter that you actually want to use inside this new node, such as this float value. Copy this by right-clicking and say copy parameter. Then go back to the Rango node and paste in this channel by right-clicking the label, paste relative reference. Now the value has been changed, value has been linked from the null value to the Rango. Then you can access to this parameter name called fval within this VEX code. And in order to access to a parameter value within the same node is actually pretty easy. What you need to do is just say, let's try to create a new attribute called val, and since this is the float value, we're going to use a chf. And for the path, we don't really need to specify the name of the node because we're in the same node. So what we just need to type in is this fval, the name of this parameter. So that is equal to fval. Now, as a result, going to the geometry spreadsheet, and you see that the val has been retrieved and set it as an attribute inside geometry spreadsheet to the point to each point. Now let me just change this to point y at p.y and plus equal so that I can change the height of this geometry. Okay, so that will be more easier to check what it's doing. So if I change the sliders, you see that the value is changing. Value is correctly linking. Now let's go back to the edit parameter interface, the parameter editor window for the null node, and change the name of this float value, say float value 2, and apply. So the name of the float value has been changed, but the value is still linked. That is because whenever you change the name of the attribute right here, if you use the copy and paste relative reference for the channel, for the parameter channel, the name will automatically change like this. So as a result, the value will always be linked, and if you don't change this attribute name called fval, then you always get the updated value even if you change the name. So that is tips that you want to remember if you want to use the parameter values within a VEX. rather than just typing the hard-coded path like this, it is always a good idea to do in this way, I think. That's what I thought. Right. So let's rename the value to fval again, fvalue again, float value again. Okay, seems to work well. Now, every time there is also a special way to create a channel or parameter value like this within the VEX code, other than going to a parameter editor window like this. That is to use a promote function for the VEX, and that is this button right here. So say you want to add another parameters like at chf, like say xval, in order to use it to move the point or the geometry to the x direction like this. But currently we don't have this parameter value called xval underneath this Rango node. And in order to use this, you kind of need to create your own parameter which have this name, but by using the chf function together with a name of the parameter, you can actually create the parameter instantly by clicking this button. So if you click this button together with having this chf channel, you can create additional parameter which has a name, which the name has been transferred from this value that you have set it. Now the value is actually could be used, is already automatically linked within this parameter together with this chf function. So that is really convenient when you want to quickly create the parameter value from VEX. Now I have tried with chf, but you can also do the same for chi, chv for integer or vector or ramp or so on. If you want to use the integer value, you type chi and say zval, and if you click this to promote the parameter, you have additional parameters, but in this case this is integer, so the value will be increased by 1. Same for vector, same for other kind of data types. So this is really convenient. You want to remember these tips. And next, I would like to explain the special parameter called ramp parameters, both for float ramp parameter and the color ramp parameter, and use it within a VEX code. And this is pretty handy, essential parameter types that you really want to remember how you can use it, because these are really useful in many cases. So let's try to do that. Okay, I'm going to create another geometry-like sphere and set it as polygon, and I'm going to create another point triangle like this, and let's set the name for this point triangle to float ramp. Right. Okay. Now I already have explained what the ramp parameter works, how ramp parameter works. By inputting an x value into a ramp value, what you get is a y value dependent on this line drawing on the parameter, on the ramp parameter for this float value, float ramp values. In the case of color ramp value, what you get is based on the position of the value, which the left hand side value will be equal to 0 and the right hand side value will be equal to 1, and depending on the position of the arrow, maybe the 0.5 should be somewhere in the middle, 1.0 will be the place that is equal to the right hand side, and the left hand side will be equal to when the value is equal to 0. So if the input value is equal to 0, then what you get is the black value, black color right here. But you can also change this color by clicking this handle, color handle, then set some random colors like this. So in this case, if the input value is equal to 0, then what you'll get is this color value of orange, so X, Y, and Z. So the float value was just one float ramp value. Float ramp parameter will just give you one value depending on the X value, but for the color ramp value, depending on the X value, what you get is three multiple values, three vector values, X, Y, and Z. And if you also change the right hand side color, now both right hand and left hand has different color, but based on the X position within this gradient bar, the color you get is the color that you see at that position, and being transferred to X, Y, Z value, which is equivalent to alg and B value. So these two works pretty much the same, just that the output value is either 1 or 3. Okay, and I would like to use that within a VEX code. So first, go to the point wrangle again, and let's try to use the first float ramp parameter in order to control the scale of the sphere based on the sliders that is in between 0 to 1. So first of all, I'm going to create a simple slider within this wrangle node, which the range is in between 0 to 1. So let's say CHF scale val. I'm just gonna name the scale name of the channel as scale val, and apply it to a float attribute called scale, or maybe val. Okay, now we don't have this parameter value yet, but in order to create this, we could click here, click this promote button in order to create a parameter. Now if I initially the range is in between 0 to 1, so that looks good. And if I change the sliders, go to the geometry spreadsheet, and this value is being stored as a float attribute. Okay, now I want to use this as an X value for the ramp parameter and retrieve the Y value out of a ramp parameter in order to get the remap value. So let's try to do that. And in order to access to the ramp parameter, there is a similar function inside of VEX like CHF or CHI, especially for the CH ramp, and that is called CH ramp. Click this, it shows a parameter, what kind of parameters you have to input in order to use this function within this parenthesis. And as a result, you can get either a float value or the vector value. So the float value, float CH ramp value could be worked for float ramp types. Vector can be used for the color vector, color ramp parameters. Now this time I'm going to use this type, right? I just wanted to need the float output. And if I look at the parameter types, I could either have a two parameters or 3 parameters. The first one looks simple, so I'm going to use this one. The first one is the name of the channel, which is equivalent to the one we have been using already. So which is this one, the name of the parameter value. And that is equivalent to these as well. So we already know how to input that. We need to input some strings for this parameter, for this function. And the difference between other CH functions like CHI, CHF, this one has a second parameter, and that is a ramp pos. And this is the value that is actually a X coordinate value for the ramp. So if you go back to a null node again, which have all the parameters, and look at the float ramp value. The x coordinate right here, you see some numbers right here from 0 to 1. So that is the value that you want to input. So within this range 0 to 1, you want to input as a ramp pos. If you input 0, then what you get is the y value of at this position. If you input 0.5, then the value you get is the height of this line, so around right here. So that is equal to 0.5, like that. But if you change the shape of the curve, then the value will change as well. If the position at the 5, then what you get right here is like 0.2 as a y value. Okay, so remember that, and let's try to use this as a scale for this sphere. Okay, now first of all, since I don't want to hard code the channel again, so I'm going to create another another ramp parameter within this null node, within this wrangle node, then link it with a ramp parameter inside a null node, so that whenever I change the parameter inside a null node, the ramp parameter inside this wrangle node will also be updated. So that's the case I want. So let's try to do that. First, I would like to change the scale of the geometry, so I'm going to multiply the point position by a ramp output value, and the function that I'm going to use is this ch ramp. Okay, so now the first parameter was the name of the parameter, ramp parameter. Since I'm going to create a ramp parameter within this wrangle node, I'm just going to name it as ramp without any node name. And the second parameter I want to input is the x value we want to refer to, and we could use this f at val, which is coming from this slider value right here. So we could copy this f at val like this. Now, in order to have this ramp float parameters within this wrangle node, we could again click this promote button, then the wrangle node, then the ramp parameter will be appeared like this. Now currently this is a straight line that is not linked with the parameter that is inside this null node. In order to link the shape, you do the same for with the other parameters. You go to the name label of the parameter, right click, copy parameter, then go back to the wrangle node and right click to the label of the ramp parameter you want to link to, then click paste relative reference. Then the shape has been shared with these two nodes. Whenever I change the shape right here, you will see that the shape inside this wrangle node also changes relative to the null node. So that looks good. Now, based on the x value right here, the scale value, the result value should be changed. Starting from 0, the value is equal to 0. But if I increase the value, the scale goes up, then at some point goes down again. This one then goes up again. So even though the x value is from 0 to 1, the actual output is going like up and down like this based on this line shape. So that is really important technique you want to remember when you want to create like custom like animation movement or something like that, or shapes or so on. Okay, and for those, right now these are straight lines, but you can make it smoother as well by maybe right clicking to one of the handle and right click and say set interpolation to something like B-spline, and do the same for other handles, B-spline, 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 and B-spline. Okay, I guess it didn't make any changes because this ramp parameters is being linked with this parent parameter right here inside the null node. So I think I needed to do that right here inside the null node. So let me remove some of the handles to make it easier to change. So right now I have 3 handles. Let's try to change the interpolation to B-spline for those 3 handles, B-spline and B-spline. Okay, now I see that I have a more smoother curve compared to the last one. So if I add more, I have something like these. Okay, so go back to the Rango node, and if I change the sliders, just by changing the value from 0 to 1, the scale goes up, down, and up again, right? So this is how ramp value works, and this is pretty similar to the color ramp value. Color ramp parameter works pretty similar to the float ramp parameter. So let's try that as well. Okay, now let's create another point wrangle. This time I'm gonna name this color ramp. Then I'm gonna create the code pretty much the same, and this time I'm going to try to change the actual color of this sphere based on the color lamp. So v at, or just at, capital C with a small case d, which indicates the point color value. Then I'm going to use the ch ramp. Let's name this ramp. Then let's also try to have a slider float value from 0 to 1 as well, named as well, like this, as a second parameter of for ch ramp. Okay, so by clicking this promote button, I should be able to get 2 values. One is the ramp parameter, and one is the slider float value. Right. So the slider value right here, and also the ramp value right here. Now I wanted to use this ch ramp as a vector value, as a color ramp value, but what I get by clicking the promote button is a float ramp types right here. So this is actually not a ramp type that I want to use in order to use as a color ramp. So unfortunately it doesn't seem to create a color types using a ch ramp, even if you have a output result to be vector. So in order to change this automatically created ramp to a color type, you have to go back to the edit parameter interface for this Rango node and click this ramp, and then change the type of ramp type from float to color. Accept, apply, and now the ramp type has been changed to color. You can now set the value to color like this. So the color changes from red to blue, the light blue, and currently the float value right here is equal to 0, so it's referring to the left hand side color, which is red, and then being applied to the sphere like this. But if I change this value right here, then it slowly moves to a blue color based on this ramp gradient bar. If I add another color on the middle and change it to something green, then if I change the slider again, from light blue we become green and then to red. Right? So this is how it works for the color ramp parameter. And you can also link the color ramp parameter from the null node to the Rango, like you did for the float ramp parameters. Just go back to the null node and copy this color ramp value right here. Copy parameter. Then go back to the Rango node and paste it right here, or the paste relative reference. Now the value has been, the color ramp setting has been transferred. Now let's set it to red to some purple light color. Now it changes from red to purple light color. Right, so that's how ramp works in VEX, how you can use the ramp inside of VEX, and it's pretty useful. You should really know how to use this. Okay, last of all of this video tutorial in this episode, I would like to talk about a little bit about parameter expressions. A bit of expressions that you can use inside a channel, parameter channel, like here. So let's bring up another geometry like sphere. Let's make it a polygon. So after you have created the sphere, let's create a point wrangle again, and I'm going to name this wrangle as global variable. So I'm going to explain how you can use a global variable in terms of parameter expressions within a parameter box, parameter channels. Okay, so in order to use them, I need to have some parameter box right here inside a wrangle node. So let's create that, and let's use that to change the scale of this sphere like we did last time. So I'm going to multiply the point position by some float value. Let's say I'm just going to name the parameter name as val. Okay, so in order to create the parameters using ch series ch based functions, I can click right here to promote the value right here. And by changing the value from 0 to 1, I could change the scale of the sphere. Okay, so what I want to do next is to use a kind of one called global variables, or global variables for the expressions inside this parameter box. So there are a bunch of global so-called global variables that you can use within this parameter input, and which can be used to create special values like a time frame. So within this parameter box or parameter input, you can use a so-called global variable, which is a constant value, can be accessed from anywhere in the network, not just on SOP, but could be anywhere within the Houdini inside this channel for those channel. And that could be, for example, like current frame values, the end of the frame values, the time in second, and so on. So in order to know what kind of global variables there are, you can check that out by going to a document page called Networks and Parameters, and under a parameter expressions page. If you go down, there is a list of global variables, saying as hscript global variables, and these are the ones that can be used inside a parameter channel as a global value. Like if you want to get the current frame value, then you use $F. If you want to get the time value, then you say $T. You might have already been using at hip. This is the directly of the file that you're saving, the hip file that you're saving at. So the lot of these are pretty useful. So try to remember a bunch of stuff that you want to use. And most of the cases, for myself, I use like $F, $Fend, $T, $hip a lot. But others are also useful, so try to check this document and see what kind of global variables are there. So let's try to use some of the variables, global variables, together with the VEX to see what can it do. Now first variables that I would like to use is $F, now which is a frame number, corresponds to this value on the bottom time frame. So if I increase it, those frame value will directly be used as a point scale value right here. So if you go to the geometry spreadsheet, you see that by increasing the time frame, the value will increase depending on the time frame right here. Okay, now if you want to set the range of this $F, which is currently a integer value, which is from 1 to 240 in this case, but if I increase the end frame, that will also increase to 1000 if the timeline comes to the 1000. But if you want to keep the range of this value from 0 to 1, even if you have the different end frame value, like from 100 to 1000, then in that case you can try dividing this $F value by an end of a flame value, which is this one. But it's not a good idea to just type a constant value like this, because in this case this works because this is set as 100, but once you have changed this to 200, then this will give you a value, the range of it in between 0 to 2. So whenever you have a different f end value, the frame end values, and keep the range from 0 to 1, then you need to use the frame end global variable instead of just using a constant value like 100. So going back to the document page, and you see that there is a specific global variable called fEnd, which will give you the frame end value in the timeline, which is this one. So replacing this with fEnd will give you a range between 0 to 1 and any case, even if you change the end of the frame value. So that is convenient when you want to create animations. And this is pretty much the essential how you can use the global variable for a parameter as an expression. In addition to this, there's also a local variable other than a global variable. And local variables are the variables that could only be accessed from specific node. Like each node inside a Houdini have its own specific local variables. The global variables can be accessed from anywhere, any node, but the local variables can only be accessed from a specific node, and each node has its own unique variables. So that are the one that is called as local variables. And let's try to use some of the local variables. Okay, and I'm going to access to that local variables using transform node as an example. Okay, now let's say I want to access to the size of this sphere after I have changed the size of this sphere using this point wrangle. I would like to get the whole size of the sphere, maybe the height of the sphere, and using that height information, I want to place this sphere on the ground. In this case, on this grid, XZ grid. So every time I change the sphere's size, I want to use the transform node to place the bottom position of the sphere to the ground position, so moving the half size up. To do that, I need to access to the Y size of this geometry, and there is a specific local variable that indicates the size of this input geometry within this transform node. So in order to check what kind of local variables this transform node has, you can check it by, say, click one of the parameters you want to use the local variables to, and then right click and go to a reference, then click local variables. And if you do that, you can check a bunch of local variables this specific transform node can use. And in this case, what we want to use is the one called size Y. This indicates the size of the Y direction of the input geometry. So let's say if I want to use this size Y and click accept, Now if you click translate, the expression has been typed automatically like as size y. So this indicates the size of input geometry in y direction. And what I want to do is to move upward by the half size of this y size. So I'm going to multiply it by 0.5 to make it a half size. So as a result, the geometry has been standing on a grid, which is standing on the ground. And even if I change the scales based on the frame, the geometry is always sitting on the ground like this by using the local expressions. So that's how you can use the local variables as a parameter expressions. And there are many other local variables that you can use for a specific node like transform. In order to check what you can use, you can either go to a reference to local variables, but this will just give you the list of its possible parameters, local variables. But in order to know more detail about those, what those variables are, you just go to a document page for this specific node. So clicking the node and clicking this question mark right here will transport you to the document page for this transform node. Then going down and you see a part called locals, and these are the local variables that you can use for this transform node. And the one that I have just used is this size y. Other than that, there is another kind of variables like xmain, ghcx, cex, and so on. So that is also essential how you can check what kind of local variables you can use for the parameters. Now there is also a scripting language that you can specifically use within this parameter box, and that is called HScript or expression functions. And I am not going to explain the detail about that because that is one big topic. So after we get used to using the VEX code scripting, then maybe I'm going to create a topic about it, create a video about it with that expression functions. But going to the document page of Houdini, there's a section called expression functions. If you go there, there's a bunch of functions listed which you can use it inside within this expression parameters, parameter input. So you can try to do a similar stuff that you use that you do inside a VEX, but directly inside the parameter box using those functions. So sometimes it's really beneficial, pretty efficient to use those stuff within the parameters. So this is one topic that I would like to talk in later videos, but for now, just remember that there are something like these stuff that you can use within these parameters. For today, this is just the basics. I just want to tell you about the global variables and local variables. And there are things called expression functions you can use inside the parameters. Okay, so that's it for the parameters, the basic of parameters you want to remember when using it together with a VEX code. So this was the basic of parameters, and in order to use the parameters with the VEX coding. And this is pretty essential when it comes to a procedural modeling, when you want to have your custom interface for your modeling or algorithmic designs. So please try to follow what we have done here, and I'm going to use the same technique that I've explained today in later videos. And the topic for the next video will be variable casting and conversion, and this will going to be a more like programming basics using VEX code. So I hope you could join that as well, and I hope you have learned something new from this video. Okay, thank you very much for watching. See you next time, and if you have found this video interesting, please try to follow the playlist, and if you could subscribe to the channel, that would be great as well. Okay, thank you very much.